If we are adding and subtracting rational expressions that have the same denominator, it's as simple as adding the numerators and keeping the denominator. However, we want to make sure that when we're done with the addition or subtraction, we check to make sure that there aren't any extra simplifications that we can do to our final rational expression. So here in our first example, we see that we have the common denominator 4x. Because the denominator is already the same, we can just add the numerators and keep the denominator. But the presence of this 20 and this 4 means I can continue my simplification to 5 over x. I wasn't able to simplify anything in the original addends. 15 over 4 and 5 over 4, there was nothing to do there. But after I made the combination, I had something that I was able to simplify, so I need to make sure that I take that step. Now, that's not always going to happen. Here in our second example, we have the difference between 9 over 16x squared and 4 over 16x squared. That comes to just 5 over 16x squared. 5 and 16 do not share any common factors, so this is the simplest that answer is going to be. No extra simplifying needed, and there wasn't any to be done in the original two rational expressions. This same logic holds if your denominator is a binomial, trinomial, or a larger polynomial. We see here that both of these rational expressions have binomial denominators that are identical. Because of that, we're able to just combine the numerators by the operation suggested. So we subtract 4x squared minus 1. We place all of that over 2x minus 1. Resist the temptation to just start crossing out the 4 and the 2 and the x and the x. We talked about that in previous lessons. But we want to make sure we're exhausting all of the possibilities for simplification. And you should notice that on the top, this is a difference of squares. Because we see that difference of squares, we should try to factor it, and it comes out to be 2x minus 1 and 2x plus 1, all over the denominator of 2x minus 1. And we saw enough in the previous lesson with multiplication, division, and simplifying to know that this factor 2x minus 1 can be simplified with this factor 2x minus 1, leaving us with a final response of 2x plus 1. Now, because the denominator was eliminated completely, we want to give special consideration, again, to those values that are left out of the domain, those restricted values of this particular expression. Back here, if I think about this being 0, even though it was simplified out of the rational expression by the numerator, if I think about that being 0, I see that x is not allowed to be 1/2. And in those situations where you've eliminated factors out of the denominator, you should give special consideration in your response to those restricted values. We know that if we were to evaluate this function, or if we were to treat this as a function and try to graph it, we know that x is not allowed to be 1/2. We eliminated that factor, therefore we would have a hole there. We didn't have to worry about that here in these first couple of examples because there wasn't any x's simplified out of the denominator. No binomials, no trinomials, no even just regular old x's by itself. We didn't need to worry about any kinds of restrictions here. But in this example, because of the elimination of the 2x minus 1, we give special consideration to that restriction. The process wasn't any different. The denominators were already the same. We combined the numerators based on the operation that we were given between the two rational expressions, and we simplify at the end.